In our previous video, we talked about trigonometric ratios of certain angles. To figure out these ratios, we took a right triangle containing these angles and then found out the ratio of their sides to get here. Building upon that conversation, let's try to figure these when our angle becomes 0 degrees and 90 degrees. Now, let me be very clear. It's impossible to construct a triangle which has an angle of 0 degrees or 290 degrees. But for the sake of argument, let's try drawing a triangle containing these angles. So I'll get rid of all the other stuff from here and let me get a right angled triangle over here. So this is a right triangle, right angled at B. Now, if we want to make one of the angles as 0 degrees, let's say we want to make a right triangle in which angle C is 0, what we'll need to do is we'll need to move this hypotenuse as close as to side BC. Let me help you visualize this. So in order to do this, I'll bring my point A as close to point B. So let's do that. So if I bring point A close to point B, now my point A is coming closer and closer to point B. So if you just stop here and look at this triangle over here, the measure of angle C is reducing. And so is the length of our side AB. It's decreasing as well. So let's keep on doing this. Let's see what happens when this point A is very close to point B. So if this point is super close to point B, point A is very close to point B, the measure of our angle C is very less now, but it's not 0 degree yet. And as we know, if our angle C becomes equal to 0 degree, angle A must be equal to 90 degree because the sum of angles in a triangle is 180. So if I move point A further down and when it coincides with point B, only then I'll have an angle which is 0 degrees. But when it happens, we don't even have a triangle. All we have is a line segment BC. So you can imagine, we cannot have a triangle in which any angle is 0 degrees or two angles are 90 degrees. And because we don't have any such right triangles, the basic definitions of these ratios, which are based on right triangles, fails in case of 0 and 90 degrees. But don't feel bad. This doesn't mean we can't figure out what these are. Just that we'd be using something more robust, known as a unit circle, to define these. And using a unit circle, not only 0 and 90, you could figure out the trigonometric ratios of various other angles. For example, you can find out what sine of 1000 degrees would be, or what tangent of minus 720 would be. And to learn more about what a unit circle is and how do we use it to define these ratios, you can watch Sal's video on it. But for now, let's make sense of whatever we know to find out what these ratios are when theta is 0 or 90 degrees. And as we understand, making a right triangle with a 0 degree or two 90 degree angles is not possible. Let's try to make something close to that. What I mean is, if I have a right triangle in which one of the angles is super close to 0 and the other one is super close, the other one apart from our right angle, is super close to 90, then we have a triangle something like this. So we have this right triangle A-BC in which angle C is very close to 0. Let's assume the measure of angle C is 0.01 degrees. And if this angle is 0.01 degrees, angle A would measure 89.99 degrees, as the sum of all the angles in a triangle should be 180 degrees. Now, as our angle A' becomes closer and closer to 90 degrees, the length of our side A'(B) becomes negligible. Its length is almost equal to 0 units. And you can also observe, when this angle becomes super close to 0 degrees, the length of the hypotenuse and side BC become equal to each other. They are almost equal to each other. So if BC is x units long, A'(C) will also be almost x units long. Now this out of the way, let's figure out our trigonometric ratios for 0 degrees. So in our triangle, A'(C) as we know is our hypotenuse, and with respect to our almost 0 degree angle, A dash B is the opposite side and the side BC is our adjacent side. So sine theta is the ratio of opposite and the hypotenuse. So opposite side is almost 0 and our hypotenuse is almost x units. So 0 divided by any number will give us 0. So sine 0 is 0. Now cosecant theta is the ratio of adjacent and the hypotenuse. So the adjacent is x units and the hypotenuse is also almost x units. So over here we'll get x by x, which is 1. So cosecant of 0 is 1. Now tangent theta is opposite upon adjacent. Opposite is almost 0 and the adjacent is x. So on dividing 0 by x, we would get 0. So tan theta is 0. And also tan theta is the ratio of sine theta and cos theta. Over here, if we divide 0 by 1, we'll still get 0. Now cosecant theta is the reciprocal of sine theta. And reciprocal of 0 would be 1 by 0, which is not defined. And you can also figure this out by this ratio, hypotenuse upon the opposite, which would be almost x by almost 0, which again would be not defined. Similarly, secant theta is the reciprocal of cosecant theta, which would be 1 by 1. Now 1 by 1 is anyway 1. And you can also do this by taking the ratio of the hypotenuse, almost x by x, which would again come out to be 1. Cot theta is the ratio of the adjacent and the opposite. The adjacent is x units and the opposite is almost 0. Now any number divided by 0 is again not defined. So I can put a not defined over here. And also cot theta is the reciprocal of tangent theta. Now 1 by 0 will be not defined. So we have cot 0 as not defined. Now let's talk about these ratios when our angle becomes equal to 90 degrees. So coming right back at our triangle, let's take the almost 90 degree angle, the A dash angle. With respect to this angle, the side A dash B is the adjacent side and the side BC becomes the opposite side. So sine theta again is the ratio of the opposite and the hypotenuse, which in this case is x divided by almost x, and this would come out to be 1. So I'll write 1 here, sine 90 degree is 1. Cosecant theta is the ratio of the adjacent and the hypotenuse, which is almost 0 divided by almost x. So 0 divided by any number is 0 itself. So cosecant of 90 degrees is 0. Tangent theta is the ratio of sine theta and cos theta. So 1 divided by 0, I cannot divide any number by 0, so this is not defined. Cosecant theta is the reciprocal of sine theta, or the ratio of the hypotenuse, which is almost x, divided by the opposite side, which again is x. So this comes out to be 1. Cosecant of 90 degrees is 1. Secant theta is the reciprocal of cosine theta. So secant of 90 degrees would be the reciprocal of cosine 90, and reciprocal of 0 is 1 by 0, which is not defined. You can also figure this out from this triangle. So cotangent of theta is the ratio of the adjacent, which is almost 0, and the opposite, which is x. So 0 divided by x would give us 0. So cotangent of 90 degree is 0. So I hope you understand how we approximated this right triangle and used SOHCAHTOA to find the trigonometric ratios for 0 and 90 degrees angle.